my channel. I am Siddharth, and today we will discuss about the topic neural network. So, firstly, we will see the table of contents. Today, we will discuss about introduction and basically what neural networks are, and then demonstrate application of neural networks using Python, using Google Colab. So, firstly, introduction. In data science, a neural network is a computational model inspired by the way the human brain processes information. It is used to identify patterns, make predictions, and solve complex problems. Through a process called machine learning, neural networks are a core component of deep learning, which is a subset of machine learning. Neural networks are a powerful tool in data science for solving complex problems that involves large amount of data and intricate patterns. Next, components of a neural network. So these are the basic units or nodes in the network analogous to neurons. Basically, they are talking about the neurons. So these are the basic units or nodes in a network analogous to neurons in the human brain. Each neuron receives input, processes it, and then result and then passes the result to the next level of neurons. Next is input layer, the first layer where the data is fed into the network. Each neuron in this layer represents a feature of data. Then another layer is hidden layer, layer between the input and output layer where the actual computation happens. A neural network can have multiple hidden layers, which is why deep learning models are sometimes called deep neural networks. Next layer is output layer. So the final layer that produces the prediction or classification results. And each connection between neurons has a weight that controls the importance of the connection. There's also a bias term that allows the model to adjust the output along with the weights. These weights and biased are learned and adjusted during the training process. Components of neural networks. So neurons. After each neuron computes a weighted sum of its inputs, an activation function is applied to introduce non-linearity into the model. This helps the network learn complex patterns. Optimization. So gradient descent in the commonly used to minimize the loss by adjusting the weights in the network, aiming to improve the accuracy of predictions. Next, types of neural networks. So first type is feed forward neural network, which is also known as FNN. And this is the simplest type where data moves in one direction from input to output. Now, second is recurrent neural networks, that is RNN, designed for sequence data such as time series or natural language where the output depends on previous inputs. Next type is convolutional neural network, which is CNN. It is very important type, and which is states that is specialized for image data using convolutional layer to detect pattern like edges, textures, etc. Now, next type is generative adversarial networks, which is also known as GAN. Consists of two neural network, a generator and a discriminator that works against each other to generate new synthetic data. Now, applications of neural network in data science. Firstly, it is used in image and video recognition. Second, anomaly detection. Then third, predictive modeling. And next, it is used in natural language processing, which is also known as NLP. So now we will see by running it in a Google Colab. So here's a Python code demonstration for using neural network with TensorFlow and Keras. The example uses the classic MNIST dataset for digit classification. This can run on Google Colab. So steps for this are: firstly, we import necessary libraries. Then second, we load the dataset. Then pre-process the data and build neural network model. Then train and evaluate the model. So as you can see here, firstly we import necessary libraries by import TensorFlow STF. From TensorFlow.keras import sequential. From TensorFlow.keras import dense and flatten. And now MNIST and matplotlib.pyplot.splt. Okay. Next, we will see load the MNIST dataset, which is X-train Y-train, X-test Y-test is equal to MNIST load data. Now we pre-process the data, normalize the image to values between 0 and 1. X-train is equal to X-train by 255 and X-test is equal to X-test by 255. Now display an example image. If we want to display an example image, we will see plt.imshow X-train of 0, CMAP is equal to gray, plt.title, label Y-train, plt.show. Built the neural network model. Model is equal to sequential, flatten input shape 2828, dense 128 activation ReLU, dense 64 activation ReLU, and dense 10 activation softmax. Now we compile the model. Model.compile optimizer is equal to Adam, loss sparse categorical cross entropy, and matrix accuracy. We use accuracy matrix in this. Now train the model. For training the model, we use history is equal to model.fit xtrain ytrain, efox is equal to 5, and validation split is equal to 0.2. Now we evaluate the model by test of loss, and test accuracy is equal to model dot evaluate x test y test print test accuracy by test accuracy of 4f. Now we will make predictions. Predictions is equal to model dot predict x test. Now we visualize some predictions by using a for loop for I in range 5. plt dot im show X test I, CMAP is equal to gray, PLT dot title predicted TF dot argmax prediction of I dot numpy, and true Y test of I, PLT dot show. As we run this, so I already run that because it takes very time to give the output. So as you can see here, firstly we will get the label 5, and these are the scale, and this 5 is printed. Now predicted 7, so 7 is 2. As you can see here on the screen, it is 7, and this is 2, then 1, then 0, then 4. So hence, we have seen neural network through Python coding also. So thank you for watching the video and stay tuned for next topics. Thank you.